Good morning, I am Srilekha, Department of Chemistry. Now I am going to take about on the topics of the atomic absorption spectroscopies. That is the spectroscopy which should have the more facilities to provide the spectras, and for that the atomic absorption spectroscopy principles, that is the atomic absorption spectroscopy is based on the atomization of the water sample followed by the absorption of characteristics radiation by the ground state gaseous atom. When the light of the required wavelength is allowed to pass through a flame having atoms of the metallic species, part of that light will be absorbed and the absorption will be proportional to the concentration of the atoms in the flame. Thus, in atomic absorption spectroscopy, the amount of light absorbed is determined. So, whenever the atomic absorption spectroscopy provides, the light will absorb the values. Next, we are going to see about the instrumentations that have various components. Radiation sources. The radiation sources should emit stable, intense, characteristics radiations of the elements to be determined. The hollow cathode lamp, which consists of a glass tube containing noble gases like argon, that is anode, and hollow cathode made of the unalloyed metal is generally used. So these is the radiation sources which are used to detect the atomic absorption spectroscopies. Next one is the chopper. The rotational wheel is interposed between the hollow cathode lamp and the flame. It breaks the steady light from the lamp into a pulsating light because the recorder will record only for pulsating the alternate current. Next one is the burner or flame. The flame is used for converting the liquid sample into the gaseous state, and it converts the molecules into atomic vapor, and two types of burner are used, that is the total consumption burner and the pre-mixed burner. So these are the burner facilities which are used to converting the liquid samples into a gaseous sample for the atomic absorption spectroscopies. And the next one is nebulations of the liquid samples. First one is the before the liquid sample enters into the burner, it is first of all converted into a small droplets, and this method of formation of small droplet from the liquid sample is called nebulations. So the liquid sample which is entered into the burner and it is converted into a small droplets, and this form of droplets which form a liquid sample is called as a nebulations. Next one is a monochromator. The monochromator selects a given absorbing line from the spectral lines emitted from the hollow cathode. The most common monochromators are prism and grating. So these are the two types of monochromators which are used in the atomic absorptions spectroscopies. Next is the detector. A detector which is used to detect the photomultiplier tube is the most suitable detector. When the photon strikes the photomultiplier tube, an electric current EMF is produced. And next one is the amplifier. The electric current from the photomultiplier detector is fed into the amplifier, which amplifies the electric current many times. So this is the formation to form an amplifier. And next one is a readout devices or recorder. The signal coming out from the amplifier is recorded using a chart recorder or digital readout devices. So working for the atomic absorption spectroscopy which has to seen, that is the characteristics radiations obtained from the hollow cathode lamp is passed out through a flame into which the sample is aspirated. The metallic compounds are decomposed into atoms of the element to be measured. The atom absorbs a fraction of radiations in the flame. The unabsorbed radiations from the flame is allowed to pass through a monochromator. So here which have been shown the monochromators from the unabsorbed radiation is led into the detector. From the detector the output is amplified and measured on a recorder. So this is the atomic absorption spectroscopy outlet, that is the tungsten anode which is to be inserted and the glass shielded neon or argon, and the HCl which is to be inserted into the tube, in the form of the chopper, and in the chopper which devices into the inject for air, and the flame which is converted into a monochromator, and the samples which will be detected which should be drained out, and the signal which produces the photocell photodetector, and the last the amplifier which produces the signal, it should be recorded as a elements. So this is the block diagram which represents the light sources and the lens monochromators, detector, amplifier, and the readout detectors. So by using the determination of the nickel by atomic absorption spectroscopy. So by using this atomic absorption spectroscopy, we are determining the amplifications of the light. Thank you.